when two young brothers, Reimer and Walter Horton, first began to design wings for the new Nazi regime in Germany. With the outbreak of World War II in 1939, the brothers continue their groundbreaking work under a shroud of secrecy. By 1941, they are exploring the use of a transport wing to help in the planned invasion of Britain. At the same time, another German, Alexander Lippisch, is working on his own wing design when in late 1941, his Me-163 Comet crosses the 600-mile-per-hour barrier for the first time. The potential of rocket power combined with a flying wing design could change aviation history. Meanwhile, the Horton brothers are going down another path. By 1942, they are working on a 61-foot wingspan aircraft called the HO-9. This would be powered by the Junkers turbojet engines that were to be fitted to the Me-262.
The Horton number 9 was the pinnacle of the brothers' development of the flying wing. And the prototype achieved a speed of something like 500 miles an hour. They had clearly demonstrated that you could build a vehicle with jet engines, that you could fly it, that it had very high speed potential, and so they had really validated the concept.
Another of Reimer Horton's designs is the HO-229. Built of wood, and with its engines housed on the wings with their exhausts vented on the top of the wing, this aircraft would have been extremely difficult to detect. But if it could have flown, it would have had a top speed of 620 miles per hour, the fastest aircraft in World War II. But while the Germans are developing their jets, a 40-year-old American aircraft designer named Jack Northrop is quietly working on a flying wing design of his own. Jack had been dreaming about flying wings since the 1920s and had long held the belief that the way to success in wing design was by reducing the drag created by a tail and fuselage.
Northrop's idea was, first of all, to minimize the tail and the fuselage, and then, as a last step, to get rid of the tail altogether. So he went through a whole series of smaller steps in order to achieve the all-wing configuration.
In December 1942, his NIM flying wing takes to the air, and over the next few years, more and more of his designs are being refined and tested. But by May 1945, the long and bitter struggle to defeat Nazi Germany is over. Its industrial and technological centers lie in ruin, along with its dream of a flying wing aircraft. But Jack Northrop is convinced that where the Germans failed, his wing will become the greatest aircraft in the world. All he would need is the raw power to do it. In 1946, Jack Northrop tests his massive 400-mile-per-hour XB-35 flying wing. Powered by 4 turboprop engines, this aircraft is seen by some as the bomber of the future.
This was where Northrop's vision really started to take shape, because the XB-35 had a wingspan of about 60 meters. This is a big airplane, even by today's standards. Its problem was that whilst its top speed was about 400 miles an hour, its speed in long-range cruise was only 185 miles an hour.
Just a year later, Northrop unleashes the new YB-49. Powered by 8 Allison jet engines, this 172-foot wingspan Goliath is capable of flying at over 500 miles per hour at a ceiling of 40,000 feet. Jack Northrop has taken the American wing off the design boards and into the air. But the YB-49's days are numbered. Although years ahead of its time, it is incredibly difficult to fly. And without computers to help control it, the U.S. Air Force feels that as a bomber, it is too unstable and dangerous. In late 1949, and in an unprecedented decision, the government orders that all Northrop YB-49s are to be destroyed. The flying wing looks destined to be dumped into the circular file of history. But the destruction of the first flying wing comes at a perilous time in history. Relationships between East and West are rapidly deteriorating, and the Cold War is heating up. The world enters a new era of nuclear power and nuclear testing. The Soviet Union has built up a huge arsenal of weapons, and the West responds. In a policy that is known as MAD, mutually assured destruction, the heavy bomber is seen as the first line of attack. SAC, Strategic Air Command, puts into place a global system called Operation Chrome Dome, in which massive B-52s would constantly patrol the Earth, ready at a moment's notice to fly to any target deep within the Soviet Union and attack. But SAC is also alarmed at the Soviet Union's new improved radar and SAMs, surface-to-air missiles. SAC is determined not to let its giant B-52 bomber fleet become a sitting target for the Soviet Union. What the U.S. needed was an aircraft that can evade the Soviet defense system, fly to its target, deliver its weapons, and bring its crew safely home. But to do this meant a completely new approach on designing and constructing aircraft. Every aircraft has what is called a radar cross-section. When an electromagnetic radar beam hits an aircraft, it bounces off anything that is large or pronounced, such as engines, straight wings, or cockpits. The radar operator sees all this information coming back and can determine the size, height, and direction of an aircraft. This is known as the aircraft's radar signature. But if you can hide this information from the enemy's radar, then the plane will become almost invisible. The mantle that will shroud the aircraft from its pursuers has a new name: stealth. The team of visionaries at Northrop have rewritten the rules of aircraft design. The technological array is awesome. With over 130 onboard computers controlling every element of the aircraft, the B-2 is light years ahead of anything yet built. A variety of techniques are combined to make this aircraft almost invisible to radar. Its smooth surface and shape consists of all curves, yet they are not consistently identical. The aircraft appears to continually change shape from whatever angle it is viewed, thereby confusing the radar, and whatever beams are locked onto it are either reflected into outer space or are reduced and dissipated into nothing. The B-2 is coated with special RAM, radar-absorbent materials, such as carbon fiber composites and top-secret reflective paint that further reduces its detection from the enemy. Finally, its electronic countermeasures, such as jamming an enemy's radar, make this aircraft almost undetectable. In fact, the B-2's radar cross-section is 1,000 times less than that of the B-52. As the 1990s draw to a close, the 21 B-2s have established themselves as one of the most cohesive and efficient bomber squadrons in the United States Air Force. They have honed their skills to pass all tests, but they have not been tested in battle.
If you are going to pay for it, it does you no good to keep it parked in a shed. And if you have an operational requirement to put ordnance on a target, why not use it?
But in March 1999, everything changes. As part of the NATO peacekeeping force, the B-2s attack highly classified strategic targets within the former Yugoslavia. Throughout Operation Allied Force, the B-2s conduct 45 sorties, often in weather that other Allied aircraft could not fly in, and produce incredible target hit rates. The B-2, if proof is ever needed, has come of age as the most awesome bomber in history.
B-2s from Whiteman flew less than 1% of the total missions, but dropped 11% of the bombs.
The technology of the B-2 is so cutting edge that the United States Air Force has the B-2 on its books until 2040.